Hi. For part 2, we're going to take a look at the derivative of the inverse of a function. Now, most functions are pretty easy. We can find the inverse pretty quickly. So I want to find the derivative of this function's inverse at x equals 3. Now we know, so we got to find the inverse first. Now to get the inverse, very easy to do. We switch our x's and our y's. So we get x equals y cubed. So my inverse becomes the cube root of x. There's my inverse. Now, but you got to remember though, this x is not the same as this x. This x is the domain, is the range. So if I know x equals 3, I also know that my y value is going to be 27. So what we're looking to find here is the derivative of the inverse function at x equals 27. And that's what we're doing here. So I'm going to take the derivative. Very simple to do. Watch how we write this. The derivative, y inverse's derivative is going to become 1/3 x to the 2/3. And then I can just plug in my 27. 1/3, 27 to the 2/3. And I simplify this. I get 1/3. Ready? The cube root of 27 is 3 squared is 9. And I get 1/27. Now the problem occurs, what happens if we have a function where we can't find the derivative? So what if, and give me a second here, I'll get my light back on. There we go. The problem is, what if we get a function that we cannot take the derivative? Or can't find the inverse, sorry about that, if we can't find the inverse. Well, we have a rule for that, and that's this. The derivative of the inverse of a function, the inverse function of a derivative at a point is the following. 1 over the derivative of the value of the inverse at that point. Big mouthful, but you kind of see it. We got it right there. 1 over the derivative of the value at that point right here. And this is our rule. So let's take a look at an example, okay? An example. Let the inverse, we want to find the derivative of the inverse at 3 if the function is the following. 1/4 x cubed plus x minus 1. Now I do this a step-by-step process. I'm going to use my rule here. I'm going to start with the value of the inverse. So step 1, I'm going to start with the value of the inverse. Find out what that equals. Remember, this is my y value. So what I'm really doing here, if I'm looking for the inverse of 3, I'm looking for x. Okay? So we're really saying this is my y value. So we're saying 3 equals, I just plug it in, right equal to this equation right here, plus x minus 1. Okay, that's my inverse. We switch our x and y's. If I plug this in for y1 on my calculator, y2, I can't solve that one, so I'm going to use my calculator. So if I plug this in, go to my graph, in y1 I'll type in 3, and then tab, I think it's tab, y2, I'm going to type in my equation, 0.25, x to the 3rd, plus x minus 1. And I hit enter. Whoa, I was looking. Why are you capitals? Okay, hopefully that won't affect it any. There it is. And I want to find out where they meet. So I go Menu, Analyze, Intersect. Enter, and I hit here. And it tells me they intersect at the point 2, 3. They meet at 2, 3. Well, we know that that's my y value. There is my x, and that's what I wanted. I wanted that too. So therefore, we know that the inverse at 3 is 2. Now we're not done yet. Now we're on the part 2. Part 2 says I need the value of the derivative at my value of my inverse. In other words, I need the derivative at 2. So I take my derivative. F prime of x is 3 over 4, x squared plus 1, And if I plug in 2 here, that's 4. As we get 3, we get 4. Simplifying it out. And now the last step, step 3, we just plug it over. 1 over this answer. It's 1 over the value of the derivative of the inverse at a. So we get 1 over 4. And there's my derivative. It's a very lengthy process. So let's take a look at another example with the trig function. Ready? So let's let, this time f of x equal cosine of x. Now for trigs, we do have to restrict the domain. Let's go from 0 to pi. And we want to find the following. The value of the derivative of the inverse at root 3 over 2. So step 1, we want to find first what is the inverse at 3 over 2. That's going to equal x. So I go root 3 over 2 equals the cosine of x. Now we know what that is. That's just pi over 6. Step 2, now I want to find the derivative of the function at that point. So I want to find the derivative, at x, at a. Sorry. I want to find the derivative at pi over 6. Sorry about that. So I find the derivative of my function. It's negative sine of x. And if I plug in pi over 6, we get negative 1/2. And our third and final step is just 1 over the derivative of the inverse at a, which we just found was 1/2, so I get negative 1. I get 1 over negative 1/2, which is just negative 2. And there we go. All right, so take a look at these. These are kind of easy, kind of fun to do. I'm lying, of course, and I'll see you guys later. Bye-bye.